Namaste, dear students. Welcome to Deeksha online bridge course. Subject is physics, and today we are going to discuss few more numericals from the topic Newton's laws of motion. So the first problem for today's discussion is a gun of mass 10 kg fires 4 bullets per second. The mass of each bullet is 20 gram and the velocity of the bullet when it leaves the gun is 300 meter per second. What is the force required to hold the gun while firing? So in this problem, we have a gun. The mass of the gun is given 10 kg. There are bullets inside this. They are initially at rest. So the initial velocity of the bullet equal to 0. When you press the trigger, the bullets are coming out with a final velocity. The velocity with which they are coming, v equal to 300 meter per second. You are supposed to find what is the force required to hold the gun while firing. When you press the trigger, the bullet goes out. The gun is pushed back. The bullet moves out with a particular force. As a reaction, there is a force acting in the opposite direction. If I find this force, it will be equivalent to this force. So to do that, mass of each bullet is equal to 20 grams. Convert it into kg, 20 into 10 power minus 3 kgs. Now the time taken, they have told 4 bullets per second. Now you can do the problem in two methods. Method number 1, 4 bullets are pushed out in 1 second. So the time taken will be 0.25 seconds for each bullet. So you take one bullet and time as 0.25, or take time as 1 second, mass to be equal to 4 times the mass of each bullet. So in a time equal to 1 second, 4 bullets are triggered out. So therefore, if you use in the formula F equal to 4m into 300 minus 0 divided by time is 1 second. I have taken time to be 1, therefore 4 times the mass. So mass of each bullet is there. You substitute that value. This turns out to be 4 into 20 into 10 power minus 3 into 300. These two zeros, this cancels with 10 power minus 3. So this will be 24 Newton. So the bullet rushes out with 24 Newton. The gun will recoil with same force in the opposite direction. I have to exert this much of a force to keep the gun stationary. This is problem number 1. I will pause for 10 seconds if you want to make a note of the problem. We move on to the next problem. A man is texting on his phone as he drives his car at 54 km per hour. He then notices a child crossing the road. So he rams his brake, bringing the car to stop in 2 seconds. If the mass of the car is 4000 kg and the mass of the person is 60 kg, what was the retarding force on the car? So here the given data, mass, total mass equal to mass of the car plus mass of the person. So this will be 4000 plus 60. This will be 4060 kilograms. It was initially traveling at 54 kilometer per hour. You see, the unit here is in second, whereas here it is in hour. So convert it into SI system. 54 instead of kilometer, 1 kilometer is equal to 1000 meter, and instead of 1 hour, 3600 seconds. On simplifying this, these two zeros will get cancelled. This is 2 times, this is 3 times. So the answer will be 15 meter per second. The initial velocity can be written as 15 meter per second. It is brought to a stop, so final velocity equal to 0 in a time equal to 2 seconds. Find the force. F equal to m into v minus u by t. Mass is 4060 into v value. Final v is 0 minus initial velocity is 15 divided by time is 2. This will be 2 cancels with this, 2030 into minus 15. This will be equal to minus 30450 Newton. The negative sign indicates the force is retarding. It is reducing the speed of the body. It is providing deceleration to the body. I will pause for 10 seconds. You can copy down the problem. We will move on to the next problem. A book exerts a force of 2 Newton downwards into a chair that exerts a force of 5 Newton downwards to the floor it stands on. What is the force that the floor will exert upwards on the chair? So in the problem, we have a chair. On the chair, you have a book. The book is exerting a force F1 on the chair. Chair is exerting a force F2 on the floor. So both these forces together are acting on the ground. The floor will give a reaction which is equal in magnitude but opposite in direction to this. So therefore, the force that the chair and the book together apply will be equal to, so the net force will be 5 Newton plus 2 Newton, that is 7 Newton acting in the downward direction. This is the force exerted by the chair and the book together. The force exerted by the floor on the chair will be same value in the upward direction. You don't have to specify minus sign here because you are using the term upwards to indicate the direction. So in the statement, you can write the downward force on the floor is equal to 7 Newton. So the upward force on the chair exerted by the floor is also equal to 7 Newton from Newton's third law. Next problem. A body of mass 2 kg moving on a horizontal surface with an initial velocity of 4 meter per second comes to rest after 2 seconds. If one wants to keep this body moving on the same surface with a velocity of 4 meter per second, what is the force required? So here there is a body of mass 2 kg. It is moving with 4 meter per second, but it comes to rest after 2 seconds. So there is a vehicle here. It is moving on the floor. As it is moving, the floor is providing a retarding force. Due to the retarding force, its velocity will keep on decreasing. After some time, it becomes equal to 0. It starts at 4. Initial velocity equal to 4 meter per second, but after traveling 2 seconds, it comes to rest. Now, if I am able to exert a force equal and opposite to this, they both will get cancelled. Then the net force on the car will be equal to 0. Then according to Newton's first law, an object will continue its motion with the constant velocity and in the same direction. So its velocity would remain to be equal to 4 meter per second. So how much force should I exert? According to the given data, mass equal to 2 kg, initial velocity equal to 4 meter per second, it comes to rest, final velocity equal to 0, time taken equal to 2 seconds. So the formula for force F equal to m into V minus U divided by T. This will be 2 into final velocity is 0, initial is 4, time taken to come to rest is 2. 2 and 2 will get cancelled, you get minus 4 Newton. This is the retarding force given by the floor to the car. If I am able to provide this amount of force in this direction, the floor is giving retarding force like this. If I exert the same quantity of force in this direction, the car will continue to move with 4 meter per second. So the answer would be apply 4 Newton force in the direction of motion. Then the net force on the car will be equal to 0. It will continue to move in the straight line with the same velocity. I'll pause. You can copy down the problem. I'll pause for 10 seconds. Make a quick note of the problem. We shall move on to the next problem. Before we continue with the problem, I would like to discuss the concept of conservation of momentum again. It states that when no net force acts on two interacting bodies, two interacting means they may be colliding with each other, then the total momentum is conserved. That means the total momentum before collision will be equal to the total momentum after collision. Say, for example, in this case, the body is moving to the right, this body is moving to the left. So this has a momentum P1, this has a momentum P2. Then the initial momentum before collision is P1 plus P2. After colliding, you see their velocities have changed. Let the new momentum be P1 dash and P2 dash. Then the final momentum will be P1 dash plus P2 dash. So according to conservation of linear momentum, as there is no external force acting on them, the force is only between the two. This may push this or this may push this. That force is only between the two. There is no external force. In that case, the total momentum before collision will be equal to the total momentum after collision. I would like you all to understand the sign conventions to be used while solving this problem, because momentum is a vector quantity. Let us consider there is an object of mass m moving in this direction with a velocity u1. There is another object of mass m moving with a velocity u2 in this direction. Now you observe both these velocities are in the same direction. Then when you write the initial momentum, P initial will be equal to m into u1 plus m into u2. Because u1 and u2 are in the same direction, you add them. On the other hand, if the first body of mass m is moving with u1 like this, the second body of mass m is moving in the opposite direction with a velocity equal to u2. Then how do you write the initial momentum? P initial will be, I will take this to be positive, then m into u1 minus m into u2. This I have taken positive. The velocity in the opposite direction should be taken negative. And after collision, let us assume in this case, first case, m after collision, let u2 increase to v2 in the same direction. But the first body now starts moving with v1 in the opposite direction. Now if I treat this as positive, I will treat this as positive because earlier for the initial I have taken them to be positive in that direction. So P final will become equal to m into v1 with a negative sign plus m into v2. You see, these were in the same direction. I took it as positive. This has become opposite. I have taken it to be negative. Same way here, after collision, the first body may move in the opposite direction with v1. U2 may move in the opposite direction with v2. Then how do I write the final momentum? P final is equal to, for the first one, I took u1 to be positive. So this direction is positive, this direction is negative. So this will become negative, this will become positive. So this is minus m into v1 plus m into v2. This is how you need to use the sign conventions to solve the problem. So with this background, let us continue with few more problems. Calculate the momentum of a basketball having 500-gram mass and 6 meter per second velocity moving towards east. So here mass of the body is given, velocity is given, you need to find the momentum. So given data, mass is 500 grams, convert it into kg, 0.5 kg. The velocity is equal to 6 meter per second. Find the linear momentum. P is equal to mass into velocity. So this will be P equal to 0.5 into 6. This will be 3 kg meter per second. The direction is to be written because it is a vector quantity. Whatever is the direction of velocity will be the direction of momentum. So you observe velocity is towards east. So here also the momentum will be towards east. Suppose they had told along the x-axis, then instead of writing towards east, you can write 3 I cap kg meter per second. Again, I will pause for 10 seconds. You can make a note of the problem. Let's move on to the next problem. In the next problem, we have two carom coins, each of mass 0.02 kg, moving towards each other at 5 meter per second. They collide with each other and rebound with the same speed. Calculate the impulse imparted to each coin because of the other. So here there are two carom coins. This is the first coin, this is the second coin. Both are having the same mass. Mass will remain the same. They are traveling towards each other. This is the first person, this is the second carom coin. Both are having the same velocity, u1, u2. So according to the data, m1 equal to m2 equal to m, that is equal to 0.02 kg. They both are traveling in the opposite direction with 5 meter per second. So magnitude of u1 is equal to magnitude of u2, that is equal to 5 meter per second. Now, once they collide, after collision, according to the data, they rebound at the same speed. So they both will collide for some time. Let's assume for a short interval of time. During this process, the first body will exert the force on the second one will exert the force on the first one, due to which they start moving in the opposite directions. According to the data, they again move with the same velocity like this. So I can write mod of V1 is equal to mod of V2 is equal to 5 meter per second. Mind you, this is only the magnitude. I am not speaking about the direction. They have asked impulse. Impulse is the effect produced by a large force acting for a short interval of time. Let's say when you have a nail and when you bang it with a hammer, the hammer will exert a large force for a very short interval of time. The effect produced by this is called as impulse. And that impulse is given by the product of force and time if these two data are given, else it is given by the change in the momentum, that is m into v minus m into u. For the hammer, this is the final momentum, this is the initial momentum. The difference will give you the impulse acting on the hammer. Same way, if you substitute for the mass and velocity of coin, you will get the impulse acting on the coin. So in our case, to find the change in the momentum, I can write this to be equal to, for the first coin, if I write m into v1 minus m into v2, this to be written in the vector form, change in the momentum. So this will be, mass is given as, I'll take mass common out, and this will be v1 minus, you observe I took, sorry, this should have been u1 and v1. I am sorry, I made a mistake here. This should have been u1 and v1. This is equal to m into u1 minus m into v1. So when I take m common out, v1 minus, okay, or I'll retain, I think I should have written here as v1 and u1. Again, I made a mistake here. I am so sorry. Should be final minus initial. v1 minus. If I take u1 as positive, v1 should be taken negative. So I put a minus sign here. This will be my u1. So this is, mass is 0.02 kg into u1 and v1 are equal, minus 2 into velocity is 5. 5 to 10, 10 into 0.202 will be minus zero point 0.2. This will be the impulse on the first block. The same would be the impulse on the second one as well, because every data here remains the same. So I repeat once again what I have done in this problem. What I have done in this problem is, I am trying to find the change in the momentum of either of the carom coins. So I am taking the first carom coin. The problem says they are moving in the opposite direction. They have same mass, they have same velocity. They collide, and after collision, they travel with the same velocity. For the first coin, if I find the change in momentum, the impulse will be given by change in momentum delta P, that is m into v1 minus m into u1. This is the initial momentum before collision. This is the final momentum after collision. Mass is common. When I pull it out, if I take the initial velocity to be along positive x, plus after collision it will be minus. So this will be minus 5 minus, the initial velocity is also 5. So this will be, m is 0.02, this will become minus 10 minus 0.2 kg meter per second. This goes to tell the momentum has changed in this direction. Whereas for the second body, the momentum would have changed in the opposite direction with the same magnitude. I would be happy if you can try that and get the same answer. We will move on to the next problem. An 8 kg cart moving at moving to the right at 2 meter per second hits a 4 kg cart moving to the left at 6 meter per second. Immediately after collision, the 4 kg cart moves to the right at 3 meter per second. What are the speed and the direction of 8 kg cart after the collision? There is an 8 kg cart. It is moving to the right at this velocity. There is a 4 kg cart moving to the left at this velocity. So, this is the first cart moving to the right with u1. This is the second cart moving to the left with this velocity. So, m1 equal to 8 kg, m2 equal to 4 kg. Before collisions, their velocities are u1 equal to 2 meter per second, u2 is equal to 6 meter per second. They collide with each other for some time, and after collision, according to the data, 4 kg cart moves to the right at 3 meter per second. That means the second cart will move in this direction with a velocity v2. v2 is equal to 3 meter per second. What about the velocity of the first cart? What is its velocity v1? You are supposed to find. So according to the law of conservation of linear momentum, there is no external force acting on the two. Therefore, if I use principle of conservation of momentum, the total momentum before collision should be equal to the total momentum after collision. For this, in the initial case, P1 vector plus P2 vector should be equal to P1 dash vector plus P2 dash vector. You need to also consider the direction. So if I write here, P1 is M1 into U1, that is 8 into 2, plus M2 is 4. I took this velocity positive here, so this velocity should be taken negative, minus 6 will be equal to, now for this body I don't know what is the velocity, so I will write it as 8 into V1 plus 4 into, so in this direction I have taken plus, this will be minus, so this will be plus. So 4 into 3. So this is 8 to 16, 6 fours 24 equal to 8 V1 plus 4 threes 12. So 12 comes to the other side. So the answer will become 16 minus 24 is minus 8 minus 12 equal to 8 V1. So this will be 12 plus 8 will be 20. V1 will be equal to minus 20 by 8. That minus 20 by 8 is nothing but 2.5 minus 2.5 meter per second. The negative sign indicates earlier my velocity was plus, now the velocity is negative. I am moving in the opposite direction. Let's move on to the next problem. I will pause for 10 seconds if you want to copy down this problem. So let's move on to the next problem. Here it's a problem related to the train. A train traveling at 60 km per hour collides with another train of same mass but it is at rest. After collision, they move together with the same velocity. Find the common velocity. So in this problem, there is a train of mass m moving like this with the velocity u1. There is another train of mass m. It is at rest u2 equal to 0. This will go and collide with this. Both of them will collide for some time. After collision, they both either may move together or separately. According to the data, they both move with the common velocity. They both join together and move together with the common velocity v1 equal to v2. You need to find that. According to the data, m1 equal to m2 equal to m. u1 equal to 60 kilometer per hour, u2 equal to 0. After collision, v1 is equal to v2 equal to question mark. There is no external force acting on them. Therefore, principle of conservation of momentum can be used here. P1 vector plus P2 vector is equal to P1 dash plus P2 dash vectors. So substituting here, m into u1 plus m into 0 is equal to m into v1 plus m into v1. Both of them are traveling with the same velocity, so both v1 and v2 I write it as v1. This term will be equal to 0 m into v1 is 60 kilometer per hour equal to m into v1 plus v1 to v1. M cancels, so v1 will be equal to 60 by 2, that is 30 kilometer per hour. In this problem, no other data is given. I don't know whether the mass is in kilogram or gram. I don't know what is the velocity u2, whether it is in meter per second. Here there is only one data. I can carry that kilometer per hour here. At this step, if you want, you can convert it into meter per second or leave the answer at this step. It shouldn't be a problem. So let's have a quick recap of the problems that we have solved today. We started with the first problem. A gun of mass 10 kg fires 4 bullets per second. The mass of each bullet is equal to 20 gram and the velocity of the bullet when it leaves the gun is 300 meter per second. What is the force required to hold the gun while firing? So to do this, the bullet was initially at rest. We found what is its final velocity. So while doing so, 4 bullets are coming out in 1 second. So when I take time to be equal to 1 second, I'll take the mass of 4 bullets. By substituting here, I get the force with which the bullet comes out. The gun will recoil with the same velocity. Sorry, the same force. Now, I want to add one more point here. Suppose we discussed about the parallelogram law and triangle law of vectors. Let's imagine there is a force F acting on the body like this. There is a force F acting on the body like this. And the body is suspended through a string. Like when you are in a swing, like this, the weight of the person is acting down, Somebody has pushed in this direction. So what is the resultant tension on the string here? To find that these both are at 90 degrees, use the parallelogram law of addition of vectors. For that, your F resultant square equal to F1 square plus F2 square 2 F1 F2 into cos theta. Here, theta equal to 90 degree, cos 90 is equal to 0. If this term becomes equal to 0, Fr square equal to F square plus F square. This is 2F square. So the resultant force will be equal to square root of 2 times F. This will be acting along the diagonal. This force will be balanced by the tension in the string. Otherwise, this object would fall down along the resultant. Same way, at the end of this topic, we were discussing the problems based on momentum. Suppose the first body is traveling like this, second body is traveling like this, the momentum is P1, momentum is P2. Then the initial momentum is found by P initial square is equal to P1 square plus P2 square. Because they are perpendicular, the cos theta term will get cancelled. Why I am saying this is, when we solved the problem there, either the two objects were traveling in the same direction or in the opposite direction. Then when they are in the same direction, you took u and v as plus, opposite direction you mentioned minus. Here they are not in the same direction, they are not opposite, they are at some angle. Then to find the initial momentum, you have to go back to your vector addition. Either use parallelogram law or triangle law, the formula would remain the same. Suppose instead of 90, if the angle between the two was 60 or some other angle theta, then this would be 2p1 p2 into cos theta. This is how you find the initial momentum if the two momentums are not in the same direction or not opposite to each other. Then we solved the problem related to the man texting while driving. He applies the brake and brings the car to a stop. What is the retarding force? We use this formula. It comes to rest v is 0. Initial velocity is given. It was given in kilometer per hour. You convert it into meter per second and substitute there. You got the answer to be minus 30450 Newton. Then we solved a simple problem related to the force exerted by the book and the chair on the floor. There we use Newton's third law. The force exerted by the chair and the book on the floor is action. The floor gives a reaction. They both are equal and opposite. Then we discussed about the force required to keep the body moving with the same velocity. A car traveling at 4 meter per second, due to frictional force, it would come to rest. If I exert an equal quantity of force in the opposite direction, the net force will be equal to 0. According to Newton's first law, when there is no net force, the body continues to move in with the same direction, with the same speed. So we substituted in this formula and found what is the retarding force. That retarding force itself is the force that I need to add in the opposite direction. Then we understood the sign conventions to be used while solving the momentum problem when the bodies are traveling either in the same direction or in the opposite direction. Then calculate the momentum of a basketball. It was a simple problem, mass into velocity. We substituted and simplified. The next one was related to the two carom coins of same mass, same velocity. After colliding, they rebound. You need to find the impulse. Impulse is the change in the momentum. mv minus mu. Initially, the first coin was moving with u1. Afterwards, it started moving with v1 in the opposite direction. So the change in momentum is mv1 minus mu1. I took v1 to be negative because it is in the opposite direction. Then we solved the next problem related to the cart. Again, it was based on sign convention. If I take this to be plus, the opposite direction velocity to be taken as negative and solve the problem. The last problem was simple. A train rams onto another train which was at rest and both move with the same velocity. The final velocities would be equal. So we tried to solve this problem. So that's it for today's session. We'll catch up after 10 minutes. As I leave, I would like to give you all a work today. I hope it would be very interesting for you. Just recollect the first ice cream that you ate. The first ice cream that you ate, where and all you ate the ice cream, which flavor you like the most, which brand of ice cream you like the most, with whom all you enjoyed the ice cream. All this from day one till today, everything related to the ice cream you have come across, try to recollect it. That's it from me. We will catch up in the tutorial session to solve few more problems. Thank you all. Take care. Bye.